Hi, and welcome back to Cloud on Air, our journey from big data into AI. So for the next 27 minutes, we're going to take a look at that journey in the financial markets. And that journey we'll talk about it in three parts. The first is about market trends. What are you seeing in the market, and what are your competitors seeing in the market? What are their pressures today that they think about every morning? And what are they going to do about it in the next year, year and a half? And the second thing we'll look at is, that in that journey, a lot of them are looking at artificial intelligence. And what I want to give you is a perspective of artificial intelligence from Google, in the sense that maybe like you, it caught us sort of by surprise just 7 years ago. And that little surprise and sort of an initial exploration has come full circle, where now most of the business decisions that we make that drive the bulk of our revenue are actually driving through AI today. And it's a remarkable journey in a very short period of time. And then we'll look at what that AI is doing in terms of now able to do a lot of things that you and I do. And as a result, it can start to alleviate a lot of the mundane and then start to do things that tirelessly you or I may not want to do, but we can now observe someone and supervise versus doing ourselves. And then with that in hand, we're now going to look at what some early clients are doing about getting into this market and figuring out how to use AI today to make a difference. And if the one message I can leave you with is that this AI, if it's catching you by surprise, that's okay. It got us that same way just 7 years ago. But right now, because of what's happening and how fast it's moving, I highly encourage you to get on that journey today, figure out how to get your data from where it is into a public cloud, and get your teams accessing this so you can be in the market and play with this like a lot of your competitors are. We can talk about a couple examples who are ready to talk about it, but most who are actually excited about it aren't yet ready to tell you, and you can imagine why. So also, as we go through this, you'll see on your screen an area where you can ask questions, and please do so. We've got a lot of Google experts sitting there waiting for your questions, and we hopefully can answer some of the questions and help you understand what we mean about AI at Google. So let's take step number one. Let's look at the market trends. What I find interesting is just a few years ago, most regulated industries did not want to touch cloud with a 10-foot pole. Now, in just the last couple of years, however, that is changing dramatically. Think of the United Kingdom. Typically a conservative stance a lot in the banking community, and they came out in 2016 and said, we see no reason why banks can't be thinking about public cloud infrastructures to run big parts of their business. That's a huge change. The second thing is to think of a company like IDC. They talk to you, they talk to me, they talk to a lot of our technology providers. And what they're seeing is that in a few short years, not only that, next year, 2018, more than half of the market, 65%, they believe, will be actively looking at applying machine learning and AI to business processes. And they're going to move beyond the tire kicking phase that many of you and others have been in for the last year and a half, and really start to reap the benefits that companies like Google and others have been seeing for a few years. So that means that public cloud's ready, ML and AI are coming just in bulk next year. And I think that's coming because of 5 major challenges that we see all customers in financial services facing. First, just look at how often your kids are using their smartphones. I mean, there's so much data being generated in images, in text, in tweets, and email. And even the sensors now are producing data, and there's new market signals for everyone to look at. So there's an exploding volume of data. Number 2, because you have a global platform now from the internet and these smartphones with billions of users, you can now compete across the globe and be headquartered anywhere. As a result of that competition, everyone's feeling margin pressure. That margin pressure is intense. And number 3, because of this angst of wanting to do the best job you can in your life, a lot of people are now figuring out where they want to move next. And so we struggle with it, you struggle with it. How do you find the right talent who knows how to take your company to be digital and how to use data? That's a third thing we're struggling with. And number 4, all this comes together. The technology changes, the people changes, the margin pressure, and all that data. Complexity is going through the roof. And we're trying to, at the same time, to protect the safety of people. Regulation and cybersecurity are paramount in every boardroom we've talked to. And finally, with all that, you'd think we'd be stopped in our tracks, but customers want us to be agile. They want us to be responsive. They want to talk to us through speakers. They want to talk to us in the car. They want to interact with us on phones. They want to have information at their fingertips all day long. which means that you and I have to be agile and responsive. So as a result of this, we see three major activities happening in the financial markets. Traditionally on-premise grid computing and HPC, that is now starting to shift into the cloud. And the main reason it's shifting to the cloud is one of the most precious assets on the planet, which is time. You can't get time back. So now we find people are trading OpEx and capital for time improvement to really rethink their business. Think of it analyzing entire portfolios, doing risk modeling, back testing. If you could move from days and hours into minutes and seconds, what might that do for many of your core business processes? A lot of the people used to have things that at the end of the day, they can now do on an hourly basis. What does that mean for how you conduct business and how responsive your customers are going to expect you to be? And we have just a few examples here of risk modeling, back testing of new models, credit analysis, regulations from CCAR and VAR. These are all requiring us to figure out how to do grid computing and burst out into the cloud. The second one is once you start to compute, that throws off an awful lot of data, the digital exhaust of all that computing, and also consumes a lot from these new sources from the internet, from mobile phones, from devices. And so now many in the financial market are saying, I want to go figure out what they call big data. How do I pull that data together and do what many have been doing for 20 years in finance, which is algo? But how do you do it on these massive platforms where petabytes feel like kilobytes? And what does that feel like? And here are a few examples. Basic market insights for signals. Time series analysis at even smaller time frames from all kinds of investment data. And regulatory reporting. You and I are both being asked to do all kinds of reports for safety, for regulatory reasons, and now we want to do the report almost using analytics and quantitative information to feel better about our decisions and what we're reporting to agencies. And then finally, you have the compute infrastructure that allows you to shrink time. You're now thinking about big data and analytics to understand what's going on. And now can you move into the phases of actually predicting behavior from clients, but also using AI to automate the mundane and really improve your processes across the financial markets. So for example, here are just a dozen different examples that we're involved in these discussions globally with many of you. So if you look at the middle column, for example, we talked about basic risk management and credit risk modeling. Those things are now using new signals created by AI and machine learning. We're seeing a lot in payments, fraud detection. There's techniques called autoencoders and whatnot, where you or I as animals, we can detect a slight hair on a huge windshield instantly. That kind of detection can be done by computers looking for fraud in those behaviors. And on the left, we see areas, for example, trading. Algo trading now embracing new algorithms I'm going to show you. And also in sales. How can I use AI to help automate call centers? Because a lot of calls are how do you shrink the time from the inbound call to the resolution so that customers' satisfaction rises, but your cost drops. And the people doing that can now actually observe and have these power tools from AI to do their jobs. So there's a big pressure building in financial markets to figure out how can I use these public clouds and AI to gain better insights. So let me take a second and show you sort of our perspective on AI at Google and how it's really driven a lot of our business. AI at Google began in 2010, and we wanted to write a new type of software. We had two teams, one that was in Mountain View and another team that was not yet part of Google in London. And they were looking at these techniques, and also in Canada, something called deep learning. And what that technique is, the software is inspired by these architectures and how you and I think as animals. And if you look inside the animal brain of the neocortex, what you'll find is that our neurons that do the thinking, they're in these stacks, these layers, if you will. And the way that, for example, recognizing images, which is a good part of the animal brain, the way that seems to work, according to neuroscientists, is that you have a picture like you see here. That picture has rods and cones in your eyes. They activate. That goes to the back of your head through this arrow, and that's the optic nerve that activates a few neurons. And some of those get excited, then they fire to the next neuron above them. And those get excited, they fire to the next one. Each firing takes about 5 milliseconds. And after a few times, at some point, some neurons higher in the stack will be activated, and you'll say, for example, oh, that's a dog. And you can, so if I show you this image, you can look at that and get it back in about a half a second or less. Now, if you were younger and you look at that, you may say, like a child, that's a cat, Mom. And the mother may say, no, no, honey, that's a dog. And what that child can do in a second and a half or less is she can adjust her weights. In other words, she can adjust the chemicals in her brain to start learning it, so the next time she sees it, she knows that that's a cat. What we found in this new type of software, deep learning, is we're replicating the architecture of that using math. And in that version, instead of rods and cones, we have pixels that we see on like televisions. Those pixels come from a camera, and they're attached to an artificial neuron. And that artificial neuron has a sensitivity to a certain pixel. That sensitivity you can dial up or down by a weight. And if that neuron finally fires, you can actually adjust how strong that signal is with something called a bias. You can boost it or you can diminish it. And that's for every neuron. And what you want to do is figure out, when you give those pixels coming in, certain ones fire, they fire to the next one, and each one is a new layer of abstraction to, at some point, a pattern at the top we label as a cat or dog. And when you make a mistake, for example, you feed it an image and it detects it wrong, what you end up doing is we have math that adjusts those weights ever so slightly so that the next time it sees that image, it's more likely to be correct. And by giving millions and millions of examples, this in 2012 was shown to recognize images as good as a 3-year-old child, which is pretty amazing. The next technique we borrowed comes from something called the hippocampus. And this is what animals use to sort of fast path that learning. In the hippocampus, that creates this dopamine cycle in your brain. The dopamine cycle is what causes you or me to fall in love and to achieve. And that cycle really sears through your brain and helps you figure out what's right and what's wrong in terms of achieving a goal. The second thing your hippocampus does is it says, don't look at one image in isolation, like the cat and dog. Look at several examples and try to adjust the weight so you average them out across that. We call it dreaming while awake, or technically a mini batch. Now I'm going to show you something from 2013, just 4 years ago, that caught the world by storm. And what they did is they took images from a video game like Atari, and they fed it into a 7-layer neural network. And they're trying to figure out not cat or dog, but to figure out, when you see an image, don't tell me you see rainbows. Figure out instead, what do you do with the joystick? Do you go up, down, left, or right? The same thing like driving a car or controlling a business process. And the reward, that dopamine cycle, if you will, the reward for this demo was basically score divided by time. The more score you get, the faster you get, the higher you get. And then the mini batch, that dreaming I mentioned, what that's doing is taking multiple screenshots, half are good, half are bad, and then adjusting weights, those biases and weights I told you, to figure out how to do better the next time. So when you hook this up, initially to play the game, it doesn't know what it's seeing. It's just numbers in and joystick out. And it tries randomly, and just by random luck, it gets a point. But that dopamine kicks in. After 2 hours playing like a teenager, this 7-layer network, pure math, you and I would look at this, we just see a bunch of numbers. It plays the Atari game better than any human. And that was astonishing. And when the team looked at this, it's one of the first examples of a general AI that actually learned by itself without any instruction from an adult or from a human being. And the next step is, I like to think the team went to lunch, but they didn't turn it off. And when they came back, after just 2 hours more, this little 7-layer network figured out strategy. It figured out the game better than the engineers that wrote the software. It figured out if it digs a tunnel on one side, as you see here, it sends the ball up high and it bounces around to get the biggest high yet. And we're going to come back to that, how these AIs are finding strategies that you or I can't describe. So we looked at this, we purchased the company, and this is Jeff Dean, who looked at this and said, well, if we apply this to a practical example, so for example, Fei Li, who was on our team, was native Chinese and Jeff was English, could we build an AI that would take the input, her sampled voice, and create English coming out on the other way and then generate English voice and do the reverse for him? If we did that, they did a back of the envelope calculation, and they thought that they would use every server Google owned in 2014. And they made a critical decision at the board level to say, we need help. And so if we're going to use this kind of computing for the human race, we need to get the best minds in the world. And let's borrow from Linux, let's borrow from TCP/IP, the internet, and the web. And the decision was made to do all that development in the open, much like Linux, and we called that TensorFlow. So we develop our AI in the open now to try to find the best minds in the world. The next thing we did is we reimagined all of our infrastructure to the point that we had a $30 billion infrastructure over 3 years, all rebuilt to think about the AI chip, the AI switch, and how to connect this on a global basis, a truly planetary computer. And we looked at this, and you can imagine the electric bill for this thing. And one engineer said, that's an Internet of Things problem. Could you build an AI to play data center like the AI played Atari? And sure enough, it works. We fed into this AI, instead of the video game, we fed it the controls of what's happening in a data center. And in the joystick we gave it were the 18 controls to set. And the high was how efficient you are using power. And sure enough, this AI, by looking at lots of examples and playing with our data center, now does far better than humans and a 40% improvement. So with that in hand, the team went after it and said, let's go after this. They had the confidence, and then they actually were able to train an AI using examples from search and from every spoken thing we can find in Android and iOS to go from Chinese to English and back and forth. And we published the paper last fall saying it actually works and is approaching and sometimes exceeding the human capacity. And we just announced a product in September where you can now have the very first version of this. It's almost like, you know, the thing you put in your ear from Hitchhiker's Guide to the Galaxy, where you can now travel and speak in your language, they hear their language, and vice versa. With that confidence, we said, could we build products that actually improve as they're using? So imagine a financial product you build where it's good when you first ship it, customers enjoy it, but the more that their customers use that product, the smarter it gets and the better to serve them. So we thought that'd be a good idea for a product design, and we did that with Google Photos. We took that deep learning I showed you before, and we injected that into Google Photos, and now every time you upload a photo and you label it, you're giving more examples to make the AI better. And as a result, this product actually improves with use. And please use it, because the more you label, the easier it is for me to find my kids' photos. The next thing we went after is it can now see, it can do control. We're finding this technique that I showed you that inspired by the carbon life forms, it can now read and write. One engineer took the idea and said, you know what? I'm going to take pictures of my email, essentially, and the label I want you to predict is not cat or dog or joystick. I want you to figure out what I would type in response to that email. That's the label of the email image. And we trained it on Gmail, and as a result, we can then tune it for you. And there's a product called Inbox you can use today, where we show you the top 3 labels, which are actually the responses we think you want to type. And when you tap, you're giving a positive reinforcement in that cycle we talked about to the AI gets smarter. And when you type instead, you're giving a native example to make it even better. And so this now, we have an AI that's actually reading and writing and automating the mundane. Think how many times in your business you have tasks where you're reading and doing basic writing that seems laborious. The next task, which we all do, is selling to our customers and providing real value where that leads to monetary exchange. A number of customers were seeing what we're building and they said, can I use that? What they meant is saying, we do a lot of ad work with you and significant spend to drive engagement for customers to buy our products. But we also have Salesforce data from a number of your competitors. Can I take those two and combine them? And can I teach an AI to play salesperson? And sure enough, this AI we've created actually is providing significant improvements in the ability to drive conversions on the web and mobile devices because it's figuring out the strategy that was hard to articulate with simple rules. And so now we have these AIs that are helping customers sell better. Another thing we looked at is business itself is not all about analytics, as you well know. Analytics are one input for you as a leader to make a decision that's right. It's about relationships and gut feel. So our research teams looked for an example of where gut feel has a lot of data. And it turns out in South Korea, Go is a national pastime. And there's statistics that go back years of all the best players. And this game from Confucius' day is all about gut feel. It's so complex, the best players in the world have 2 gut instincts. 1, who's winning or losing? Pure gut. Number 2, what move? Pure gut. And as a result, by looking at millions, we were able to train 2 AIs that replicated the gut feel of the best players in the world. And just a few days ago, we published research where it's now playing itself and has far exceeded any human in history for playing Go. And that's all about using an AI to actually capture human gut feel that many of you and I do in business. Now, we also looked at the task, which was hard for us, it's an existential task, of could we build an AI to play AI researcher? So think of the game of orchestrating those neural networks and setting up those architectures. Could we build an AI to outdo an AI researcher? And we called that AutoML, and we began this less than a year ago. What I can like to share is that the research, the very first research published on this was August this past year, and just a few months ago. And we found that sure enough, we can build an AI on a planetary scale that outdoes the best researchers in the world on the simple task initially of labeling images. And what you see here are two different lines. The yellow line represents the best humans in the world, where you see the y-axis is accuracy and the x-axis is model complexity. And the models are getting bigger and fatter, but with human endeavor. The blue line is like that Atari game I showed you before. It initially does pretty well, it's better than some of the best humans, but it figures out strategy. And we now find it figured out a strategy we can't articulate, but it's using systematic exploration like AlphaGo to beat AI researchers themselves at their own game. So we're now taking these capabilities of which I talked about, it's selling, it's perceiving, it's reading, it's writing, it's feeling. We're turning that into simple APIs so that AI to you feels like using the search box. And so on the left here, we have simple APIs that do things like speaking, looking at watching TV, video intelligence, looking at natural language. Those are APIs available by the click, and you can play with them now. And on the right, we actively encourage you and your teams to participate in open source with TensorFlow, and let's all contribute to make this a fantastic tool for the planet. That's TensorFlow. And then in the middle, we have a platform we've built inside Google that allows us to use this across 8 properties with 1 billion users. And if you ask a machine learning researcher, they'll tell you it feels like playing with a spreadsheet next to a fireplace. They don't feel the weight of those billions of dollars of infrastructure and thousands of cores. It just feels lightweight and responsive. So now a number of clients are actively using this across the board in financial services industries, in insurance, and in unregulated parts of the industry, in hedge funds and large banks and whatnot. And we have a few that are willing to talk about it right now. And I think a lot of you, as you get into this, hopefully you have the same joy we do in using these tools. And let me show you a couple of basic examples of where we're driving people. One company called AUCA is in Europe, and they're driving a platform for doing mobile banking that if you looked at Kenya or Nigeria, that's the way they do banking all by their phones. Some of the largest banks tend to be telco providers. And so AUCA is looking for a very secure platform to start figuring out, can I do better insights to focus on my customer set? And they needed something highly secure on a planetary scale, and that's what drove them to actually start to move their data into Google Cloud. And so this is a live, a company at the edge of the avant-garde of banking, now driving towards AI because now they have their data in a place where it's possible. Another company, what many of you know, is Citadel. Been around for a long time. It's a very, very large hedge fund, and they're doing a lot of grid computing, and they are trying to figure out, can they trade their own capital and expense for time? Because time is most precious, especially in the financial markets. And they're bursting from on-prem into the cloud, initially 40,000 cores, and significantly shrinking time to let them start to reevaluate how they conduct the financial risk and how they actually conduct their business. Because these tools just weren't available just a very few short years ago. And they're riding that investment that we've driven to be AI first inside Google. Lloyd's Banking Group, an Augusta bank that's been in for a long time, they too are looking at seeking for time and using time to shrink time to then get better insights. So you see the pattern here, right? So you're getting your data, you're trying to move it to a cloud to get ready to shrink the time it takes to get answers, and use that extra time to get better insights to serve your customers. Lloyd's is following that pattern. And they were able to take a process that took them 96 hours, multiple days, and they shrunk it down to half an hour. Imagine what that does to you and settlement and other banking tasks. If it used to take almost a week, now you can do half an hour. What could you do with that, and how better could you spend your time? So I hope I showed you today examples of what's happening of AI financial services. We began with a look of the market itself. And like you, there's a lot of complexity you're facing. Data's coming at you, regulations coming at you, Customer demand is skyrocketing, especially through mobile devices, through new smart radio devices and whatnot, and even intelligent cars. They want to do banking and interact with you in insurance in all kinds of ways. And finally, customers, though, they also want to figure out what's best for them. And so you and I are in a constant war for talent to find that right talent. And what that's leading a lot of us to do is figure out, how do I get data collected and put in a place that can now get insights and go find AI results? And then we looked at Google itself. And maybe to you, AI is relatively new, or your leadership, certainly. And in that case, we were caught flat-footed too in 2010. But now if you look at that, we've gone from curiosity to driving the core of our business to the point where research now, we're showing early signs in the research community of building AIs that can finally take advantage of a planetary scale platform to do the AI task itself. And so with that, we've been trying to bring that to market in a rapid way, and we need your help to engage with us. And as you do that, push us and we'll push you of how do you actually use this to build a great tool so that when you're using AI, it should feel as simple as SQL or as a search box. And that's our ultimate goal, and we'd like to work with you on that. And then finally, I give you a sense of what some early customers are doing who are willing to talk about it. And what they're driving to is they want to move from on-prem into the cloud for security, which is new for a number, as well as to get data in a platform that's highly performant. And once they get their data from on-prem into the cloud, they want to do better insights, but shrink the time. Go from days to minutes, and minutes to seconds, and use that free time to either provide additional value to users or then use and train machine learning models. And so I hope today that you have a chance and ask us in these online prompts any questions you have about AI and how to get started at Google. And we've certainly enjoyed some success at Google applying this to our revenue and our core business. And I highly encourage you to go back to your teams, and I want you to be the AI expert in your company, where you're now going to be a champion to say, how do I get my data into public cloud, shrink the time, and start providing the insights that only AI can do. So thank you very much for your time and attention today.
Absolutely. And now we'd like to welcome back fans of the Industry Solutions track. Now, Joanna, have you been enjoying the session so far?
Absolutely.
Good.
Like I said, I love learning, and honestly, I'm impressed with how much there actually is to learn, even for someone like me who's on the cloud platform team inside of Google with constant exposure to cool things. It never stops. Like, there's so much more out there that you might have missed.
Absolutely. And now we've been joined by the Big Data track. Next up on the Big Data track, we've got a session on fast tracking Apache Spark and Apache Hadoop with Google Cloud Dataproc, and that's presented by James Malone.
For the AI track, Yufeng Guo, my friend and fellow developer advocate, is going to talk about machine learning at scale, running TensorFlow in the cloud.
Outstanding. Now, in the Industry Solutions track, Praveen Pillai, Global Lead of Retail Industry Solutions on Google Cloud, is going to present how to deliver targeted experiences to retail customers.
And remember, in case you forgot in the last 30 minutes, we have a live Q&A open throughout the entire event, so you can join the conversation and get answers to your questions by clicking on that question icon. And we have a hashtag.
We do. It's Let's Talk AI. So absolutely get on your favorite social media and talk about what you're seeing today, any questions you have. We'd love to have you all join and be part of the conversation.
The other thing about all platform events, about all the platforms here at Google, but especially Google Cloud, is we really care about our developers and their own experiences, and that's why we try so hard to get your feedback, both on these live sessions and the content in them and the speakers, but also about the entire cloud API and the offerings there. So please feel free to always let us know what you're thinking, both today and online in Stack Overflow, in our communities, just all over the internet. We're here to learn and listen and make better products.